modulus of x plus 9 by x, and this is less than 9 plus 5 by x, and we are asked to find out the number of integral values for which this inequality is satisfied. If you are looking at the expression which is inside the modulus, it is equal to modulus of x plus 9 by x. So let us just look at it. X plus 9 by x, if you simplify, will be equal to x square plus 9 by x. The numerator, which is x square plus 9, is always positive, and the denominator is positive if x is positive, and it is negative if x is negative. Or basically, the expression which is inside the modulus is positive if x is positive, and it is negative if x is negative. So let us look at both the cases. The first case is when x is greater than 0, and the second case is when x is less than 0. If x is greater than 0, the inequality will become equal to x plus 9 by x is less than 9 plus 5 by x. And if x is less than 0, the inequality will become equal to minus x minus 9 by x is less than 9 plus 5 by x. Or we can simplify this as x plus 9 plus 14 by x is greater than 0. Or this would imply that x square plus 9x plus 14 divided by x is greater than 0. In this particular case, x is less than 0. So if you multiply the entire equation with x, the sign of the inequality will change. So x square plus 9x plus 14 has to be less than 0, or this will equal x plus 2 into x plus 7 has to be strictly less than 0. This would imply that x has to lie between minus 2 and minus 7, which are the roots of this quadratic equation, x plus 2 into x plus 7. If this quadratic equation has to be negative, the value of x has to lie between minus 2 and minus 7, and this is strictly less than, so it cannot equal minus 2 or minus 7. So the value of x can be either minus 3 or minus 4 or minus 5 or minus 6. This is in the second case where x is less than 0. If x is greater than 0, the inequality will become equal to x plus 4 by x minus 9 is less than 0, or this will be x square minus 9x plus 4 divided by x has to be less than 0. In this particular case, x is greater than 0, so if you multiply both the left hand side and right hand side with x, the sign of the inequality will not change, because here x is greater than 0. Or you want x square minus 9x plus 4 to be less than 0. This is not a simple quadratic equation. We were not able to factorize it like we have factorized in the earlier case, but we can simplify this as equaling x into x minus 9 plus 4 will be less than 0. If we are ignoring the plus 4 for a moment, x into x minus 9, the roots are equal to 0 and 9. So we can check for all the terms. If we make x to be equal to 1, the value of x into x minus 9 will be equal to 1 into minus 8, which is minus 8 plus 4 will be less than 0. Similarly for 2, 3, 4, 5, 6, 7 and 8, all of these are again between 0 and 9. You can check the value will be of x into x minus 9 will be less than minus 4. So it will be true for all of them, but when you make x to be equal to 9, the value of x into x minus 9 will become equal to 0. So 0 plus 4 will be greater than 0. And for any value of x which is greater than 9, both x and x minus 9 will be positive. So the entire inequality will also be positive. So in this particular case, the only values of x which satisfy the given inequality, which is that x into x minus 9 plus 4 has to be less than 0, are x is equal to 1 or 2 or 3 or dot 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 till 8. Again, just to reiterate, the reason we have checked this way is because we want x into x minus 9 to be initially less than 0. Because if x into x minus 9 plus 4 is less than 0, it would imply that x into x minus 9 is less than 0. And for x into x minus 9 to be less than 0, the values are 1 to 8. And each one of them, at each of these points, the value of x into x minus 9, we can manually check, will be significantly less than minus 4. So x into x minus 9 plus 4 will be satisfied when x is equal to 1 or 2 or 3 or dot 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 till 8. So there are 8 cases in the first instance, and there are 4 cases in the second instance. So the total number of integers which satisfy this given inequality will be equal to 12.